Testing 1, 2, 3. All right. Well, unfortunately, I don't have a fire alarm to get everybody started this morning, but I'll try to keep everybody awake and interested. So, my name is Arlen. I'm the president and CTO of Cirrus Link Solutions, and what I'm going to talk to you about today is using the components or the technologies from two of the Eclipse Foundation projects, one being Paho, the other one being Tahu, and how you can use those in conjunction with the industrial Internet of Things and digital transformation. So a little bit about Cirrus Link and myself. I've only been doing SCADA for 41 years. I got out of Oklahoma State in 1978 and went to work for the Koch brothers. Koch had just started an oil company in Medford, Oklahoma, and they were building pipelines to take ethane from Medford, Oklahoma to Mont Belvieu, Texas to the plastic plants. So as the first electrical engineer they had ever had, I said, what do I do? They go, well, you can do anything you want. So I got to run the ditch witch. I got to put 6-inch conduit in the ground, take a backhoe, pull the double-lock copper wiring to 5,000 horse Westinghouse motors, wire up those motors, connect those to Toshiba vacuum tube starters, wire all that to a brand new Modicon PLC. And remember, 1978, Modbus had just come out. It was the latest and greatest technology. So, and oh, by the way, that PLC was only about the size of a refrigerator. Then wired the I/O from the PLC to an RTU, connect the RTU to a Bell 202 modem at 300 baud on a multi-drop phone line. All those multi-drop lines went back to Medford, Oklahoma to a DEC PDP 1144, and that's where we ran our SCADA software. Now, you can say, well, you know, that was 1978. But the fact of the matter is, we're still architecting industrial control systems pretty much with the same technology. Yeah, the computers got smaller, the networks got faster, they became more ubiquitous, but the way that we think about industrial control systems hasn't really changed in the last 40 years. So, along my career journey, about 25 years into it, after dealing with all of these crazy protocols, from Modbus to HART to DMP 3.0 to Tejas to ABB ROC protocol to Emerson version of DMP 3.0, I had an opportunity. And that opportunity was Phillips 66 had just gotten their brand new TCP/IP-based VSAT system. Now, realize in 1998, if you said anything other than RS-232 or RS-485 in the SCADA or telemetry industry, they really didn't know what you were talking about. But Phillips 66 needed to take advantage of shared space segment. So each remote site had about 218 baud of aggregate throughput. So how could they connect their flow computers and their PLCs in the field to multiple applications that wanted to consume that data and use less bandwidth but respond quicker? And so that's when I had the wonderful opportunity to work with an IBM fellow. His name was Andy Stanford Clark, and Andy and I invented this thing called MQTT we released the first spec in 1999. And what really pisses me off is that MQTT's been around for 21 years, but Facebook were the first people to actually adopt it in mass, if you will. So really, if you look at it, when we started, I think the reason MQTT has been so virally adopted and is so popular is that we had to solve a problem. We weren't trying to invent anything to go out and dominate a market. We were just trying to solve a problem. First thing is, yes, it had to run on a Z80, an 8-bit Z80 with 32K of memory. So it had to be efficient. It had to be simple. It had to be efficient in that we needed to eliminate 95% of the bandwidth overhead. So we needed to send the same amount of data faster using 90% less bandwidth. One of the things when people read the MQTT spec, that they don't quite realize is, what's this state thing? So everybody likes MQTT. Oh, we can publish this, we can subscribe to this. But very few people read on to say, what is the state management of MQTT, and why is it there? Well, the way that we're going to reduce bandwidth is we're going to publish everything on report by exception. But you talk to a SCADA manager, you talk to a plant manager, say, oh, well, I'm going to control your valve, I'm going to control your 5,000 horse motor, but I don't know if the device is going to be there when I send the command, but hey, we'll try. No. The reason MQTT has state is that I can have 1,000 booster stations for Phillips 66, and I know the state of every one of those edge nodes. And if those fall off the network, you're notified immediately. And I'll show you a little bit more about that here in a little bit. And lastly, the ironic thing is that Andy and I actually did the first cut of MQTT. We did it in about 3 months. It took us 9 months to negotiate with the IBM lawyers that it would be open. This is 1998. This is IBM. You didn't do things open. So I'm happy to say when we released the first MQTT spec, it was an open source license. And really, that was amazing at the time. Now, some really things I want to point out real quick. I'll go, well, first of all, MQTT is a first-class TCP/IP citizen. Andy and I were tempted to go UDP. We were tempted to create our own transport. But no, we put it on top of TCP/IP, which leads to number 2. The spec doesn't define any network security. They go, oh, Arlen, OPC-UA defines security. DMP 3.0 defines security. Well, go back and look at number 1. MQTT is based on TCP/IP. If we would have defined how to do security, I wouldn't be here talking today. But the fact that MQTT can move at the pace of whatever the latest technology of TCP/IP security is. And the last thing, we didn't define a topic namespace, and we didn't define a payload. I was so tired of register-based protocols that said, oh, in Modbus register 40,012, you're going to put this. And oh, a 32-bit floating point, we didn't think about that. But let's magically put 2 Modbus holding registers together, and we'll call it floating point, and you guys get the gist, right? So with that, real quick, so if I look at what is pub/sub, basically you need a server and you need an MQTT client. And there's very few verbs in MQTT, and so the clients connect. And then if one client wants to say something interesting, one client is interested in something, it can subscribe. And in this case, it's going to do a wildcard subscription. And the client on the right is going to say, well, I want to publish a message on the hello/world topic, and the payload is going to be an ASCII string saying hello from a client. It publishes that. The MQTT server processes that and says, who is subscribed to this hello world topic? It could be 1 client or it could be 1,000 clients. Now, that's the decoupling aspect of MQTT, is that you can have a one-to-many architecture. You can publish 1 process variable and have 100 applications all receive that. So then that is delivered on that topic. Now, real quick, again, this isn't an MQTT tutorial, but I think for this audience, for industrial, this is how state works in MQTT, is that if you read the spec, in the connect session, you provide a username, a password, and a last will and testament. You don't have to supply it, and most people don't. But what is a last will and testament? A last will and testament is an MQTT message with a topic, PLC 07/death certificate, and a payload of PLC 07 is offline. You create that in the session, and now that last will and testament is saved inside of your MQTT server. It just sits there, okay? It's sitting there. Now you have another client, and you can go on and you can publish and subscribe. So life is happy. You've got your IP socket, and you're publishing and subscribing. Then another client comes in, and he says, you know what? I want to know when that guy falls off the network. So he does a subscription. He subscribes to all the death certificates. So now we're running, and Now somebody trips over the Ethernet cable, pulls the Ethernet cable out of the switch, and that network disappears. Now at that moment in time, the MQTT server detects that we've lost that client out in the field, and it publishes the last will and testament on behalf of that client that's no longer there. Now this is really kind of the key premise of MQTT and the efficiencies that you can get. You get continuous session awareness, but it doesn't cost you bandwidth to keep that up. Right? Think about why we poll. Why do we poll? Is the valve open? Yes. Is the valve open? Yes. Well, I don't know. I better ask again. Is the valve open? Yes. So we burn incredible amounts of bandwidth in all of these protocols by asking for data when this is 2019. The devices can tell us, but we've got to give it an architecture to be able to do that. Now, with the simplicity of MQTT, this is the 2018 Eclipse Foundation survey, I'm happy to say that in the 2018, and Frederick, I don't know how you asked the questions, but in this survey, you can see that MQTT is here. AWS IoT uses it, Google Cloud Platform uses it, IBM Watson uses it, Microsoft Azure uses it. I give talks at college universities, and I say, you know, I was at Oklahoma State, and I had about 100 engineering students. I said, of you students that want to go into automation, how many of you have ever heard of OPCUA? Raise your hands. Heart, you know, DMP 3.0. But I asked that same audience, how many of you have a Raspberry Pi in your dorm room? Every hand went up. How many of you are probably using Node-RED and MQTT? Again, all the hands went up. So my point is, why don't we take advantage of a technology that isn't sequestered just to the industrial sector, to that control engineer that's sitting in cubicle 7, but let's make it applicable for our whole infrastructure solution. Now, the good thing about MQTT, and I think the reason it's so widely adopted, is you can publish anything that you want on any topic. You could publish a Modbus binary payload on foobar. You could publish a JPEG picture, XML document, a JSON document. But the bad thing about MQTT is you can publish anything that you want on any topic. So when we started Cirrus Link about 4 years ago, we were going to technical conferences and everything, and I started asking people. I asked Opto22, oh yeah, we use MQTT, and Hilscher and Moxa, and then you saw that AWS IoT started using MQTT, and of course IBM Watson have had it since the beginning, and Google Cloud Platform, and nobody was doing it the same way. So we had a common transport, but we didn't have any interoperability. So myself, the developers at Cirrus Link that have all been using MQTT for the last 20 years for real-time control systems. I will have to say that Phillips 66, we put that system in 1999. They've been running 14,000 miles of pipeline, 1,000 booster stations, 5,000 Allen Bradley PLCs, 1,200 flow computers, 500 truck terminal and tank gauging systems with 5 nines of availability for 20 years. So, you know, I talk about MQTT, oh, that's bleeding edge. It's not bleeding edge. It's been around forever. We're just now trying to figure out how to best use it. So what does Sparkplug do? Sparkplug is we sit down and said, you know what? MQTT was invented for real-time operational systems, but if you're going to use it for that, this is probably a really good place to start. So the first thing that we did was we said, you know what? We need to come up with a standard namespace that everybody can agree on that makes sense in the industrial sector. Now, if we have a standardized namespace, that means that I can have clients that don't know what you have, but they can go down and subscribe and they can discover what you have. Number 2, MQTT was designed to be lean and mean on high latency, unreliable networks. Now, what's happened here recently, and this is great, all the cloud platforms took over and they started doing MQTT, but they made you publish everything in JSON. JSON is great. I have nothing against JSON. But if I'm on a VSAT system, on a cellular radio system, on a 900 megahertz spread spectrum radio, I don't have unlimited bandwidth. So what we did was we kind of took a middle of the road. the first payload that we did for Phillips 66 was pretty cryptic binary, okay? This is the middle of the road in that the Sparkplug spec defines a Google protocol buffer schema that's optimized for process variable representation. Okay? So what that means is I can now look at process variables as objects and not as register value pairs. Very important as I go through this discussion. Thirdly, we defined what this state management thing was. If you're running a SCADA system and you're talking to PLCs and tank gauges and gas chromatographs and cathodic protection systems, then if you've got thousands and thousands of edge nodes, then how do you manage that state? And how should a SCADA system or an operational system know when things fall offline and you set all your tags stale? And then finally, we defined some high availability architectures addressing both redundancy and scale. Now, all of that was great. We started getting a lot of traction with Sparkplug, and I'll show you kind of the ecosystem we've been building up. But after about 3 years, we started getting the questions from the Chevrons and the Phillips 66 of the world on, okay, who owns the spec? Does Cirrus Link own the spec? Does inductive automation own the spec? What if you decide to change it? So we took all of the specification and we took the reference implementation code that we did in C, Java, JavaScript, and Python, and we, last June, I believe, Frederick, we basically gave all of that to the Eclipse Foundation, and it now lives under the Eclipse Tahu project. So if you want to find out anything more about Tahu and Sparkplug, it now lives at the Eclipse Foundation. Okay, so if we take that all into consideration, and you think about, I know I did a TED Talk about 5 years ago on just kind of MQTT in general. And at that point in time, I kind of compared it to, here we are talking about the Internet of Things. We were talking about the Internet of Things 6 years ago. Why isn't it happening quicker, right? Why can't it move at the scale of the Internet of People? Well, the Internet of People happened because of two things. One is there was an open, available transport called HTTP. And then once that was there, somebody came along and said, oh, what if we had a representation of what we put on HTTP? We'll call that HTML. And those two things together took off, and the Internet of People happened. Well, then the Internet of Things kind of came along, and we were interested in, we'll just publish small pieces of information. It won't be mission critical. But if we're going to look at the industrial Internet of Things, I don't think it's going to scale till we can come to something that's very equivalent to the Internet of People. That is a transport that is well known, that's open, that's highly implementable on just about any platform from an Arduino up to a definition of what it is that we're publishing, which is Sparkplug B. And really, as you look at the adoption of that, that gives us the kind of the tools that we need to go forward on. If we could have a transport and a representation, then I think we would all move a lot quicker. And both of these technologies are open. So with that, now that I've got some tools and I've got some definition, maybe, what's the steps to digital transformation? How do we go to a customer that's got an industrial control network and say, if you're going to put together a migration plan to move from legacy poll response to digital transformation, but still have the same architecture, you got to start thinking differently. So the first thing is decouple. Connect devices to infrastructure, not to applications. And that is the hardest thing if you're talking to conventional SCADA, control engineers, plant control systems. Nobody's thinking this way. They're thinking, well, IBM came in or Microsoft came in or, I'm the poster child of how not to sell this. For 15 years, I tried to sell MQTT-based telemetry SCADA by going IT down, and that never works. What we have to do is we've got to enable OT. We've got to enable the operations technologies to change the way that they think, to change the way that they put their architectures together. So if we think about it, again, this is 2019, taking advantage of all of the technology that we've got now. Let's design devices or edge devices that let us take those and connect them to infrastructure, not to applications. Number 2, provide a single source of truth for all tags. I'm putting in a control system. I've got 5,000 PLCs. I've got 80,000 tags. I'm using Modbus or OPC UA, polling Modbus or DMP 3.0. I've got 80,000 tags now that I have to configure. When I get a Modbus register 40,012 and it's got a value of 1024, what is that? Is that gallons? Is that feet? Is it scaled? Is it already in floating point? I don't know what it is, so I have to double click on it. I have to edit it. I have to edit 80,000 tags to give them context, give them engineering units, give them scaling factors. What we should be is, again, this is 2019, those devices should be able to tell us everything that we need to know about every process variable. It should be self-discovered, and nobody should ever have to edit a tag again. And finally, step number 3 is we've got to prove that this is a better, faster, more scalable, more secure, more available operational system first and foremost. Because if we can't get operations to buy off on this, we're not going to get access to the 99% of the data that's being left in the field, because operations are satisfied with the data that they're getting. They're not going to change the way they do their network infrastructure. So the reality, or the dream, right? The dream of when we're talking about the Internet of Things, cloud computing, artificial intelligence, predictive maintenance. I've seen the presentations from everybody. They're great. They draw great pictures. I'm not making fun of them. They do have the tools, right? They'll show you all the tooling that they've got. And then they have this little line down to, oh, and yeah, you'll just get all your OT data. Well, that's where everything goes off the rails. Because the reality is that's the hard part. The hard part is getting an architecture together that lends itself to being natively consumed by IT, so that then you can go to any of the providers. They've got the tooling now, but you've got to think about it, again, differently, in that you've got to get OT involved very early on in these projects, especially in the existing heavy industrial applications that we're all going after. So this is my world, right? This is a 1994 Automate flow computer. If you take that top circuit board off, you'll find there's some EEPROMs under there, right? The best in cybersecurity. You're not going to hack that system unless you can reburn the EEPROMs remotely. Well, this is our world. We've got to take that 1993 piece of equipment. It's still a perfectly good flow computer. How do we get that to play in our digital transformation infrastructure? So, what if we could take that device and have the technology, let's say an edge device out at the edge of the network, to be able to get that Modbus holding register from 40,027 with a value of 126, and then be able to take that at the edge, using the Sparkplug spec, transform that into an object. Right? So now, let's give it a tag name. Instead of 40,027, let's call it section pressure. Let's give it engineering units. Let's give it engineering high, engineering low. Oh, we could give it a timestamp. A timestamp that could survive as that tag went through the system. Because we don't do that today, right? So we'll put a UTC millisecond timestamp right at the origin, the single source of truth. And we'll provide the current process variable. But that's what we're doing. We're saying that we're going to transform register value pairs into objects that then we can start consuming, because now when the IT folks get that information, there's context that goes along with it. So, again, Sparkplug is just a little over 3 years old now. It just went public on Tahu in June. And we've already got a significant infrastructure of cloud providers, device hardware manufacturers, and application providers that have implemented the Sparkplug spec or are looking to implement it. So we're starting to get quite especially on the device hardware, from Opto22, WAGO. I was at the Offshore Technology Conference in Houston. WAGO is one of the top manufacturers of PLCs. They've implemented Sparkplug now. Opto22 provides it. Redline, Digi, Omron. So we're starting to get there, but we're just scratching the surface. So one of the things I want to do now is say, anybody that's interested, now that we've got a Tahu working group, I'm trying to get as many OEM device manufacturers, application solution providers, infrastructure providers, so that we can get this thing off of top dead center and start using the tools that the Eclipse Foundation gives us to be able to take advantage of all this. So, final slide. So let's go back. So we've got these tools. We've got MQTT. We can go to Paho and get all the tools we need there. We've got Sparkplug. We can go to the Tahu project and download the spec, download the reference implementation code. And now we want to start building out an end-to-end topology. So the first thing is we have our operational data out in the field. We have, and we've done all this from wind farms to tank farms to electric substations to water and wastewater to chemical plants to pharmaceutical, food production. Now, we've got devices out at these locations that pretty much that whole ecosystem of manufacturers that I told you about. But now, instead of polling, let's think about this a little bit differently. Let's put in an MQTT server infrastructure. We can put in as many MQTT servers as we want. One of the things that's very unique about MQTT is that if you have one server that fails, you can fail to another one. It just morphs over. So I told you that Phillips 66 has 5 nines of availability. They also have 6 MQTT servers. Got 2 in Ponca City, 2 in Bartlesville, 2 in Chicago. So out at their booster stations, if they lose one of the servers, it just morphs over, republishes all of its information. So all of a sudden, redundancy, high availability, scalability become just as simple as plugging in another MQTT server in another availability zone. Now, one thing I forgot to mention from a security standpoint, I told you we're already leveraging TCP/IP, TLS, SSL, SSH, whatever technology your IT department want to use. But the other thing that's very unique here is that I don't have to have ports open out in the field. MQTT is a remote originated connection. So if I have 1,000 edge nodes out in the field using MQTT, I don't have 1,000 ports open. I've got one port open in my DMZ, and it can connect to any one of n number of MQTT servers, and I can put TLS. So I turn the power on. Oops, I've got to add my networks. Turn the power on. Boom, get a remote originated connection. I've got my TLS certs, got my MQTT username and password. I've registered my last will and testament, and I'm publishing information. So these devices all power up, they all connect, and we've accomplished step number 1. These devices are connected, and they're telling the infrastructure about all of their interesting information. Oh, you just changed pressure transmitter from PSI to kilopascals. Oh, you just changed the flow rate, the orifice plate on a flow computer. Oh, you changed the strapping table on a tank. All that information is feeding into this infrastructure. So now, next step is I got to take, from an operational standpoint, find our operational host. This may be a SCADA system, it may be a plant control system, and it, with an MQTT client, should be able to plug into that infrastructure and learn about every device and every tag in a matter of seconds. Not man-years of double-clicking on tags, but learning that by getting a Sparkplug message in. Go, oh, I know you're a stamping machine. I know you've got a stamper, a reeler, and a dimension photo system or dimension system on there. I know what to do with you, right? So now, from an operational standpoint, we've got a single source of truth, and we've got a superior operational system. So at this point, I've kept everything on the right side because what I'm saying is that the operations guys need to know this is a better solution than what they've got now. We're not going about it. We didn't draw all the cloud. we drew an operational system that works for operational folk. But now, we've got the infrastructure we need. We're completely MQTT based. We've got a standard with Sparkplug. So now, uniquely, now this is unique. In every other SCADA system, you can't, once you have your infrastructure up, you can't put another SCADA system right beside it because it's not decoupled because you're using a protocol. But with MQTT, I can have another client come in and subscribe to everything that's being published. And maybe this client publishes all of that then to my cloud services, right? So now I've got a path to taking either all of the information or a subset of the information, or I can take the information and augment it. But now I'm starting to get flow to where I can just plug in applications into this infrastructure. So we've got partners like OSI Pi, Canary Labs, Seek. Those are applications that have taken the Sparkplug B spec, implemented it, and just plug it into the infrastructure. Automatically learn everything that's there. So my point is that we've got to build infrastructures using available technology so that people can plug and unplug applications. In our sector, I believe we've lost a lot of the innovation. It's called the serendipitous nature of data. If I hard code or if I tie into a PLC or any sort of a manufacturing device with a protocol, pretty much I'm stuck day one. Yeah, day two, you could piggyback on, you could plug other things in, you could get spider web networks around the edge. But my point here is we've got one infrastructure that's taking care of all of the needs. We don't need to have a separate, oh, I need an IIoT infrastructure, I need an IoT infrastructure. That gets crazy. They don't last, they don't scale. But if we can get to an architecture like this, this lets our customers know that it's secure, know that they're getting the information they're in, and there's all kinds of dashboarding you put around this. You can measure latency, because you know when you publish something, you know how long it took to get through the broker. So we're measuring latency and jitter, and almost becomes a network diagnostic tool in and of itself. So the last thing I'll mention here is that everybody that I put on here, Ignition ABB, Moxa, Ignition Edge, Wago, these are all commercial available products. What I'm talking about, this technology, it's not a pipe dream. It is being put into production today. Phillips 66 have been using it for 20 years. Plains Midstream have been using it for the last 7 years. So really, I think with the power of the Eclipse Foundation, and what we're doing here with Tahu is disruptive. Because if I was any other organization, I would go to the Instrumentation Society of America, you know, ISA or IEEE. But guess what? ISA don't have a GitHub. They don't have a Maven repository. They aren't looking at software licenses like the Eclipse Foundation. I love Mike Milinkovich's presentation. Software is eating the world. So if we're going to take this and push it into the industrial sector, we should go to an organization whose job it is to manage software. Because I think it's getting out of the realm of defining what RS-232 is or defining what, you know, Ethernet levels are. Now we're moving in a completely different direction that I think this is going to set a precedence for. So with that, that's pretty much the end of my presentation, unless there's any questions.
We have maybe 5 minutes for a few quick questions.
Okay. Great. Oh, I thought I explained it so well that nobody was going to have any questions.
So close. So on the right side, leveraging MQTT, can you remote update the items that are at the edge?
Yes, well, part of the Sparkplug spec you'll see is that you can publish files, you can publish configurations. So it is not, so some of those customers have implemented remote, so then it's down to the way that you implement Sparkplug. But if you wanted to publish a file that was a binary update, let's say a patch to the Linux operating system or a patch to your configuration, then yes, you could publish that. Sure could. And you could subscribe to that at the edge side of things as well. Over there.
Thank you. Sometimes state of the device is defined by more than one variable. assuming you have a very unreliable network between the infrastructure and your sensors, how do you handle the atomicity?
Okay, that's a very good point. So you have state, okay, at the MQTT connection level, which is a TCP/IP socket connection, that's binary. You're either on the network or you're not. But now let's say you're connected to an Allen Bradley PLC and a HART transmitter and a DMP 3.0. The Sparkplug spec gives you quality for every tag that you're publishing. So I could have a good state on my edge of network box that says I'm connected, but the tag that's coming from my HART transmitter says that that is last known good because my HART comms failed. So you've got the metadata that you need within the Sparkplug spec to go all the way down to a tag level. If you had multiple devices on that edge controller, you're going to know the state of each of those devices, the state of all those tags of those devices, and you're going to know the state of your connection from these devices into your MQTT servers. You don't care, you do care, but if your HART transmitter dies, the edge of network device is there to tell you that it died. That's not a problem. The problem is when your device, your edge of network falls off, then these consuming applications back here that are subscribed to that death certificate, they can take corrective action to know, okay, my entire Opto22 device fell offline. Now everything coming from that device is stale. It's last known good.
All right. So thank you very much, Arlen.
Thank you.